In our previous videos, we've seen how a pair of linear equations can be solved graphically. Will the graphical method be suitable for all kinds of linear equations? Take this pair of linear equations for instance. If you plot the graphs of these two equations graphically, you will realize that the solution is not very obvious on the graph. The correct solution is x equals 1.6 and y equals 0.6. Now this is not something we could probably see correctly on the graph. So when the solutions are not integers, the graphical method is not suitable. And that's when algebraic methods come in handy. There are three types of algebraic methods we will look at: the substitution method, the elimination method, and the cross multiplication method. We've already covered the first two in our previous videos. Here in this video, we will cover the cross multiplication method. Before we look at how we implement this method, I need to show you how it's derived. The derivation is pretty simple to understand, and once you go through this video, you'll be able to do it yourself. To start off, we write the pair of linear equations in the general form like this. This is the general form we've seen many times in our earlier videos. Now what we need to do is to find the values of x and y in terms of these six constants. How do you think we can do that? You're right. We can use the process of elimination. To get the value of x, we need to eliminate y. To do that, we multiply the first equation with b2 and the second one with b1. Doing that will give us equations 3 and 4 like this. The first equation was multiplied by b2 throughout to get equation 3, while the second one was multiplied by b1 to get equation 4. Notice that the coefficients of y are the same in equations 3 and 4. So we can easily eliminate y by subtracting one equation from the other. Subtracting equation 4 from 3, we get this. As this term will equal 0, y will be eliminated and we get this equation. Can this give us the value of x? Absolutely. Dividing both sides by this expression will give us the value of x. And how do we get the value of y now? Easy. We just substitute this value of x in the first or the second equation. This is the value you should get for y. This is assuming that the denominator is not equal to 0. b2a1 minus b1a2 will not be equal to 0. Rearranging this tells us that a1 over a2 will not equal b1 over b2. If this condition is satisfied, then the cross multiplication method will give us the values of x and y directly using these formulae. There's only one problem though. How do you remember these formulae? We know the concept now, but how do we remember this? It's pretty simple. Using equations 5 and 6, you can derive the following. How did we get this? Simple. We just transpose the numerator on the right to the denominator on the left for both the equations, after which the right-hand sides became equal. Now remembering this also may be difficult, but there's a diagram which will help us in doing that. We write the constants like this. Under x, we have b and c. Under y, we have c and a. And under 1, we have a and b. How does this diagram help us? We just mark 6 cross or diagonal arrows from the left towards the right like this. Isn't it simple now? X over b1c2 minus b2c1, y over c1a2 minus c2a1, and 1 over a1b2 minus a2b1. And looking at the diagram will tell you why it's called the cross multiplication method. So what's the point of this method? It gives us the solution just with these formulae. No need to eliminate or substitute. We just need to keep in mind the assumption here, that a1 over a2 is not equal to b1 over b2. Only then will the pair have a unique solution. Now what if they're equal? Do you remember the cases we'd looked at while graphing equations? These were the three cases. If the two ratios are equal, but not equal to C1 over C2, then there will be no solution. And if they are equal to C1 over C2, then they will have infinite solutions. In the next video, we will solve an example using this method.